Welcome, everyone. Thank you for joining us today. Our topic is classification and information extraction with a focus on PDFs. If you've been attending some of our recent webinars, we've covered a lot of topics around Gen AI in particular. So today we're going to kind of pivot to predictive, but I think it's worth pointing out that the more I look at it, the bigger the role of predictive even within Gen AI development. And I'm not going to give it away, but we'll see a little bit of that later here in the demo. Our featured speaker, however, is Grace King. So Grace, want to introduce yourselves to everyone?
Yeah, thanks, Shane. Hi, guys. My name is Grace. I'm a senior product manager here at Snorkel, and I'm really excited to be here today to talk to you guys about the value of PDF extraction, specifically how we do it at Snorkel. All right, I'm going to dive right in. So, as I mentioned, today we're going to be talking about unlocking the value of your most complex and high value PDF documents in an enterprise setting. At Snorkel, we often refer to PDFs as the hidden gems of your enterprise data. And there are kind of three reasons why. Um, PDFs carry really rich layout information like tables, charts, and paragraphs. And understanding all of those is essential for understanding the full context of a document. They also archive your company's really most critical documents, things like signed contracts, financial statements, legal agreements. Often PDFs are the most valuable type of data that a company has. They also serve as key data sources for really like mission critical enterprise systems. Back at SnorkelCon in October, we actually polled our audience and asked them what percentage of their enterprise data they would estimate are in PDFs. And the majority of the people we surveyed said 50% or more, and a lot even said like 75% plus of their data is in PDFs. So, as Shane alluded to, let's talk about Gen AI in the context of predictive PDF Snorkel Flow. This is a really, really exciting time in the world of Gen AI because of the advancements that are being made in multimodal models, things like LLMs. Today's largest models can process and understand images, layout informations, PDFs better than ever before, which is a huge game changer for unstructured data. But despite all of these advancements, we've learned from working with our customers that out of the box, LLMs are just not sufficient for handling complex domain-specific enterprise documents like PDFs. They might be good at some of the simpler use cases, but for most enterprises, your PDFs are pretty complex, and you want to make sure that whatever you're using is as accurate as possible. We actually did a case study with a top 10 US bank with unstructured CLO documents. And that showed that out of the box LLMs plus Llama Index were only 25% accurate, which in my mind, that's a really concerning number. That would be a fail grade. So, let's dive a little bit deeper into the key challenges with PDFs. I like to say extracting values from PDFs is not as simple as just walking into a vault and retrieving gold. It's more like mining for gold nuggets. You have to do some work to really get that value. But when you do the work, the value is immense. So there are some key challenges. One is just the rich layout complexity of PDFs. As I mentioned, multimodal models contain technical limitations in understanding the full context of a rich layout PDF. And longer documents pose significant challenges for current models, especially considering context windows. There's also the factor of document sensitivity. PDFs often contain sensitive business critical information, and that's not something that you want to be putting in a public model because you're risking data security. Um, and your models often require training on company specific data for you to get any value out of that model. Finally, there's a high performance bar. As I said, often your PDFs are mission critical systems, and that means these models are going to require high compute performance. You're going to need scalability, and you need to factor in things like cost efficiency. And that makes this process even more demanding. So the good news is Snorkel Flow is here to help. And I'm going to talk a little bit about how we help and what that looks like. So at Snorkel, we can transform raw PDFs into what we call AI-ready PDFs by programmatically labeling and structuring the data. And all of that enables downstream AI systems to process the data with higher accuracy and scalability. As I mentioned, most models today, even though they've improved, they're still not great at handling unstructured data. And so at Snorkel, we help you take that very rich unstructured data and make it structured and really ideal for a model, an LLM or otherwise to process. So we're going to take a closer look at the process of transforming a raw PDF into a PDF that's AI ready. So it all starts with pre-processing. At Snorkel, you can start with scanned or native PDFs, and you can use our out-of-the-box OCR engines like Tesseract or Azure Form Recognizer to digitize those PDFs. Then we get into data prep. We use this step to get all of the information from the PDF that you'll need for downstream development. We do things like extracting text using parsing, extracting layout information, things like your paragraphs, your page numbers, metadata. We also do object detection for things like tables, checkboxes, and lines. You can use page filtering to focus only on the relevant content for your downstream use case. You can define your own entities. And we also have out-of-the-box templates for common entities like dates, email addresses, and other stuff. So once you've extracted all of that rich information, the next step is structuring. You can classify your PDFs into categories like loan documents or service agreements. And you can also do extraction of relevant information like key value pairs, tables, paragraphs, or other specific entities that you define. So this is a look at the end-to-end workflow that shows how Snorkel transforms these raw PDFs into structured usable data. And now that we've talked about the process in theory, let's take a look at a real-world example in Snorkel Flow. So our first demo today is a hot topic in the world of Gen AI. There's a RAG use case. The customer here, Shield Healthcare, wanted to build a chatbot to answer health insurance policy questions. But this chatbot was facing issues. We identified retrieval errors as the source of their problem. To put it in simpler terms, their chatbot was struggling to parse key sections of their PDF data, and it was lumping the wrong sections of data together to answer these questions. This error caused the embedding model that they were using to train their chatbot to kind of train on the wrong information and retrieve false answers. And because embedding models are trained on public domain data, they often don't work well with your enterprise domain specific data. All in all, the last thing you want as a company is a chatbot giving your customers the wrong answers. That is not going to end well. So the way to solve this problem is to fine tune an embedding model. And that really requires associating the right questions with the right document chunks that have those answers. So we're going to take a look at how to do that within Snorkel in this video.
I have an application here to show you how this works. It's Snorkel. Snorkel has tools to parse PDFs and allow you to chunk them into paragraphs. In the interest of time, I'm not walking through those steps. I've already completed this and I've loaded these documents into Snorkel. These are healthcare insurance documents that I'd like to label with questions related to like common user questions for it. So things like, does my plan cover a specific treatment? what is the eligibility criteria, what are the key exclusion criteria, and so on. So we want to label different sections of this document to map to specific questions. So just to give you a sense of what the data looks like, you can let me scroll through, and you can see that the parser has parsed and like split this into paragraphs. So a really simple LF would be this example here. So we know that the table of contents is not really relevant to any specific question, and we don't really want to map it to any question here. And so we're labeling this as other. And I know that the table of contents has these, like these dots. So I can use that to like automatically like remove these examples from consideration. So a really simple LF to do this would be the keyword count LF. And I would say if the rich doc text contains the pattern dot 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 dot, and if this occurs more than 5 times, then label it as other. And so you can see that this is really accurate. It has 100% precision, and it's successfully picking up all these like table of contents pages that we don't want. So this is great. So we're going to go ahead and create this LF. I'm going to also like show you how to create an LF that's specific to domain context. So as you might be aware, for a lot of Americans, health insurance is tied to employment. So there's a federal law called COBRA, which requires large employers to offer an option to like continue healthcare coverage even when the employee leaves their employer. And so a really common question for an employee might be, what are the terms of the coverage when I'm searching for a new job? And so in order to like label this, we're going to look for Cobra as a keyword. So let's say let's use a keyword LF and say if the table of contents section contains Cobra, then label as if I'm laid off, what are the terms of my coverage when I'm searching for a new job? Okay, so this is pretty accurate. I can also look for it in other contexts. So maybe I can say if the span itself contains the value Cobra, like that would also be relevant to this particular question. And so now you can see that like this is actually really good at picking up information related to your coverage when an employee is searching for a new job. So you can see like changing your Cobra coverage, when your Cobra coverage ends, a lot of relevant examples here related to all of this. And so all of this can be fed into an LLM system downstream, which can then generate the answer that the user is looking for. And so you could use Snorkel's candidate-based approach to label key question context pairs for your specific use case, and then use this downstream to like fine-tune your embedding model.
So what we just saw, by fine-tuning their embedding models using Snorkel Flow, Shield Healthcare was able to associate specific questions with the correct document chunks, and that improved their chatbot's accuracy significantly, making sure that their customers were receiving the correct answers to really important questions that they were asking. So in that example, we used something called candidate span extraction in Snorkel Flow. With candidate span extraction, you pre-extract spans of text that are relevant to your use case. Then you annotate and write labeling functions for some of those spans, and then train a model to predict the labels for every span in your data set, in this case, your PDF. Candidate span extraction is great for simpler use cases with homogeneous entities. And we have off-the-shelf templates to help with a variety of use cases using this approach. But what if your PDFs have more complex entities? That's why we have our new word-based extraction approach, which allows annotation, writing labeling functions, and model training on every single word in a PDF. And what this does is it offers greater flexibility when handling complex workflows. So how might a customer use this today? We're going to talk about Pixel Electronics and how they tackled a really interesting use case. Pixel was trying to build a knowledge base using their own patent PDFs. But as you can imagine, patent PDFs are packed with all kinds of complex information, things like patent numbers, filing dates, titles, assignees, so much more. And off-the-shelf models were just not cutting it for them because there were too many different types of entities to extract. So they turned to Snorkel Flow's word-based approach to solve this problem. So we're going to take a look again at how this works. So you're going to start by collecting ground truth from subject matter experts. We've got this patent for hot tubs that you're working with. Here are a list of entities that you're hoping to extract from this document. You start by drawing a bounding box on the patent number, maybe the date of the patent, the application number, the title, and your filing date. Then you can go through the rest of the data to gather a few more data points, and awesome, you've got ground truth from your subject matter expert. Once you've fed that back into Snorkel, your data scientist can take it and scale it up with programmatic labeling. Once you see this data in Studio, the data scientist can hover over each of the annotations and see how it's been classified. This gives them some sense of patterns and provides inspiration for them to write some labeling functions. They can write labeling functions for any word in this PDF. One of the first things that they can do for labeling functions is prompting. We support prompting LFs in Snorkel Flow. In this example, we're going to use GPT-4o. I've already written a prompt that specifically to extract patents. If I click into it, you can see that I've just used natural language to ask, what is the patent number in this document? I'm going to click View Correct, and I'll see the votes. And you can see that it's been pretty good at extracting some of these patent numbers in the PDF. So this gets me pretty far, but what if I want to customize it? I can also create word-based regex LFs to create labeling functions based on positional information of the word. First, I'm going to look for the regex pattern that matches the patent number. Then I'm going to find the positioning of the words in the same row to the right or left of the patent number. Once I've written this, I'm able to select the label and preview the labeling function. As you can see, it has successfully identified the patent number on the top right. So this looks pretty good to me. We're seeing 100% precision score. So I'm going to go ahead and create that labeling function. Once it's created, we can now see the LF on the left and all of those metrics associated with it. And the metrics look awesome. I'm going to continue doing this for the rest of the entities in my dataset. Once I have a good training set with programmatic labels, I can start training my new model to predict a label for each word in this PDF. We have a models tab with a lot of options for model training. I'm going to start by leaving it on the default settings and then click Train Custom Model. And awesome, that's all you have to do to train your first model. So once the model has run, we can take a look at the metrics. As we can see, this F1 score is only 50%. I think we can do better. So to do so, you're going to scroll to the Analysis tab, and we want to take a look at the class level metrics. I saw that the metrics for the patent class are especially low, so I'm going to take a look at the confusion matrix to see what's going on here. Looking at the matrix, I can see that it's predicting on the negative class, even though the ground truth is patent. So I click on that and the dataset filters for that condition. And I'm able to look through my dataset to see what points are meeting this condition. Using this error mode, I'm able to write more labeling functions to properly label this document. I noticed that most patent numbers start with US and end in 2B. So I'm writing a regex to capture that and label it as a patent. What this does is it increases the number of training labels that I have for the patent class, and that's going to improve my model performance. Another way you can do error analysis is by writing negative LFs. In our earlier video, we talked about negative LFs. Here I have an example to capture the references cited in a patent PDF, because that's not something that I care about extracting. So when I look through my data points, I realized, hey, I don't want to capture this, and I'm going to label it as negative. Awesome. I also realized that I don't care about the abstract, so I'm choosing to also label that as negative. I'm going to adjust my negative label, and I've decided that I don't want abstract, so I'm labeling that as negative as well. And now we see that we're getting a precision score of 100% for this. So we've done a lot of work improving our labeling functions and the training data set. So now we're going to go ahead and train another model just like we did before. And after a few iterations, we are going to have a model that has a higher F1 score of 74%. That's awesome. And by the end of this process, Pixel Electronics was able to successfully transform their patents into structured data, enabling downstream AI systems, and build a really robust knowledge base of their own patent data. To quickly recap both of our demos, we looked at two different approaches for extracting information from your PDFs. The first used candidate span extraction, and the second used our new word-based extraction. By offering you both, we ensure that you can tackle any use case in Snorkel with ease, from your simplest use case all the way to your most complex workflow. We really want to make it as easy as possible for you to handle whatever you need to do. So what's coming in the world of PDFs at Snorkel? This is just a quick sneak peek of our PDF roadmap. So be sure to stay tuned for announcements about more advancements in the near future. So today we've talked about the fact that PDFs hold a lot of valuable information, but that information is very challenging to unlock value from. Snorkel Flow helps optimize PDFs for AI use cases by enabling the creation of structured and labeled data from your unstructured PDFs. And Snorkel Flow provides an end-to-end comprehensive solution for all of your PDF needs. And I think we have time for some questions.
Absolutely. Nice job, Grace. So we do have some questions building up here, and we also have some time. So as we work our way through these questions, feel free to add more questions along the way, whether those are related to the demos you saw today, or Snorkel Flow, or even AI ML in general. Grace and I are happy to answer any questions that are coming off our way. I'm going to kind of start with one of the first questions here, and I can kind of tackle this one a little bit. Does Snorkel present the extracted labeled info in a multi-model context or as text for the LLM to process? So where I wanted to level set a little bit is that, yes, as Grace had mentioned, kind of in the beginning, using an LLM is usually kind of the first attempt, right? So if you have some documents, why not send them to, GPT and ask, if it can provide, specific information that you're looking for. And sure, for fairly simple documents, it's probably going to work. And if it does, great. But what we found in practice is that, we've worked with customers with, 3, 4, 500 page, financial and legal contracts, right? They're very dense. They're very complex. And sometimes to make things even harder is there's variations in them, right? Dates can be in different formats. They're not consistent. So sometimes those large language models are not going to be as accurate as you need it to be. So in this case, Snorkel Flow is actually doing the extraction and the labeling itself, right? So some of what you saw in the demo via those labeling functions is we are internally going to train a predictive model that when past these PDFs can basically extract the information you're looking for. So we're not dependent on an LLM, but also, as Grace showed us, we can certainly use that to help too, right? Why not? We have the ability to ask, GPT or Llama or Mistral or whatever model you might be choosing to help extract that information. But when we see that it's only coming up 60, 70% accurate, we can add additional label functions to help us get to 75, 80, 85, 95% plus accurate. So hopefully that answers your question. Feel free to rephrase it or ask if I didn't, but that's what I wanted to kind of make clear to everyone is that what we're talking about is doing the extraction within Snorkel Flow without needing an LLM, but we can certainly take advantage one to speed things up or to help if we like. So hopefully that helps a little bit. Here's another interesting one, Grace, that I think might be touching on kind of the pre-processing. And I know we didn't cover it specifically, but the DAG pipeline underneath is, does Snorkel use tools, for example, spell check, to clean text from the OCR process to improve performance or further extractions?
Yeah, so our DAG pipeline has a lot of different functions in it. Off the top of my head, I can't remember the exact tools that we use. So maybe this is something that I can email you and follow up with a more specific answer to really drill down on exactly what you're looking for.
Yeah, the same. I don't know if I know the exact spell check tool, but and maybe next time we'll have to add some slides to cover it. Is during pre-processing, you can customize the steps that happen early on. So ideally, we're trying to take your PDF and we're going to convert it into our own kind of internal rich text format. But a lot of things happen along that way, whether it is chunking or it is creating those candidate spans that Grace had mentioned. So you might say, hey, I want you to pre-identify any numbers or company names or dates or finances, things along those lines. And that's certainly a place where you could insert something to do, for example, spell check or transformation or anything else that you might need to pre-process that PDF. So those capabilities are in there. Some are out of the box. Some are available to you to add, as you see fit. You can work down the list here. So this is an interesting one. And I could probably handle it superficially, and we might have to get back to you on more details. But how does Snorkel handle inconsistencies in parsing table data? What I can offer from that perspective is that our parsing is actually tailored for a lot of different structures that you would see in PDFs, and tables is one of those. So it is specifically built to be able to process and handle tables, which it does really well. And I know the video moved quickly, but you might have saw a little peek there when one of those PDFs was scrolling and there was actually a table there. So it does a fairly good job. I'm not familiar with any areas where it's created inconsistencies. I'm not sure if you've seen anything like that, Grace.
I can't say that I've seen inconsistencies specific for parsing table data, but one thing you might have noticed in our second demo is that on our first pass, using prompt LFs, not everything was identified correctly. And so that's a huge reason why we have annotations from subject matter experts to establish ground truth, and also custom label functions, because you want your data scientists to be able to go through and see, hey, this table might not have been parsed correctly. Again, I haven't seen that personally, but it's certainly possible. And they can then correct that information to make sure that the training data that you're using for your downstream use case is as accurate as it can possibly be.
Yeah, I saw this next one come in, and I think what we're was that click to pick feature. I believe that was when we were seeing the bounding boxes being drawn. So Grace, you'll have to help me if I veer off the wrong path here. But that first demo was using candidate spans. Those candidate spans are identified ahead of time by Snorkel Flow during the pre-processing. So by the time it gets to you, we've already identified all the potential candidates for what you're looking for, whether that's financial numbers or dates. The alternative we saw with the word-based is you can simply draw bounding boxes around any group of words that you're looking to tag. So I know it kind of went pretty fast when we were doing the demo, but as you draw that bounding box around, say, the patent number, for example, there was a little pop-up that kind of brief, was very brief. But in that little pop-up was all the different label options for the things that you're looking for. And so as soon as you click one of those, you've now labeled the contents of that bounding box by whatever that was. So I think that's what you're getting at, because I saw that question come in real time, and I think it was when we were watching the bounding boxes get drawn. So again, if that was not quite right, feel free to ask that question again, but I think that's what he was getting at. Let's see here. Okay, so this is another one, and I've seen this one before in other webinars, and we don't always have the perfect answer for you. Is how many docs have to be annotated for training? There's probably two lenses to this. I guess one is how much ground truth you need, and the other is just how many documents have to be labeled, even pragmatically, before we build a highly accurate predictive model. In my experience, that answer has varied. It really depends on the performance you're seeing. Oops, sorry. Depends on the performance you're seeing and is in the error analysis. So I know we saw a little bit of that, looking at the confusion matrix, the clarity matrix.
Yeah, I would say
What would you say?
it's very use case specific. And I don't mean to say that as a cop-out answer, but truly it depends on the, as Shane said, the accuracy that you need for your use case, but also your data. You might have really well formatted PDFs that like you can just do a couple of annotations and it's able to learn really well from that. Or you might look at our error analysis and realize like, hey, that wasn't good enough. I need to add annotations and labeling functions to a couple more of my pages in order to get the quality I need. So the nice thing about Snorkel Flow is it gives you that flexibility. You could try out just a couple of annotations, just a couple of labeling functions. And if you're at a high enough F1 or whatever metric score you are evaluating, awesome, go with that. Or if you realize, hey, I need to iterate on this a little bit more, you can go back and improve.
Yeah, I think the one thing I would probably add there too, in terms of scale and what some of our customers have been doing, and also just kind of a quick reminder is that the labeling functions that you saw today, and I know we didn't go, into great detail in labeling functions, but their purpose is to, kind of label these documents on your behalf, right? So yes, there is a small amount of ground truth as much as needed to help you with, error analysis and validation. But we have customers who've processed, hundreds of thousands of documents. And this can sometimes take it as little as days. And it's not necessarily days of you doing work, right? Sometimes it's just days of the system going through all these PDFs and doing the work. But these labeling functions that you saw in a few minutes here, that is pretty reflective of the real world, right? You're looking at, some of these examples in real time. People have sometimes spent, I would say on the order of hours, experimenting with labeling functions. Once you've created those labeling functions, there really isn't a limit on how many documents you can apply them to. If you have 1,000, apply them to 1,000. If you have, we had someone with 500,000, apply them to 500,000. The whole kind of design principle here is that you are not going to manually extract information from 500,000 documents, right? We
I
just
mean,
clues
you
and
can
say,
imagine you can imagine how time and cost intensive it would be to pay subject matter experts to extract data from 500,000 pages. Like I am shuddering just at the thought of that.
well, yeah, and I think this touches on, kind of another one. After labeling functions like this have been created for a certain type of document, could the AI go through 100 docs and export, each extracted entity, for example, into a spreadsheet? And the short answer is yes. Although, just to be clear, we don't have a button that will create a spreadsheet for you. But yes, once you run the model, you could have theoretically, extracted entities for any number, of documents, and you could hop into a Jupyter notebook, which is also within Snorkel Flow, and you can certainly write some Python to grab those entities, export them to a spreadsheet. I've also seen people simply insert them into a database. But the one kind of caveat I would put there, I guess, is there's kind of two steps. There's that first step of the training data, right? Maybe there's, say 10,000 documents and we've applied labels to them. And then we use that to actually train a predictive model. Ideally, you will deploy that predictive model, and then going forward, you'd be pushing any new documents through that predictive model. And they'll be extracting those entities for you. And how you handle that is clearly up to you, right? If you want to grab them and put them in a spreadsheet or a database. So it really kind of depends. Is this more of a batch thing, or I just want to label these 10,000 documents? Certainly, you can use a Jupyter notebook and take care of that in Snorkel Flow. Or are you trying to build and deploy a predictive model that will help you extract, the next 10,000, 100,000 documents, going forward?
Yeah, and Shane, the thing you touched on with the Jupyter notebooks is one of the things that I love most about Snorkel. Even if we don't have a magic button to do the specific thing you want to do, being able to use our SDK and write notebooks to really like customize so specifically for your use case is, to me, it's invaluable.
Yeah, definitely. Here's a great one. Great presentation, Grace. Thank you. So appreciate the feedback. And I'm sure, Grace does as well. The follow-up question on that one is really, I think we're trying to find the ratio between subject matter experts and data scientists that we've seen, from our customers to achieve these outcomes, right? So if you do have a data science team, how many SMEs are going to be needed, to help get through this process and get that super highly accurate predictive model?
Yeah, I think this also depends. Depending on what customer we're working with, sometimes they have a team of in-house or contracted subject matter experts, and that can be a really large team, or it can just be like one, maybe two people. And so we we make recommendations to our customers about maybe how many SMEs they might need. But really, it kind of depends on the amount of data and the complexity of the data that they need to annotate. Um, and on the data scientist side, like we've seen again customers with whole teams of data scientists, but we've also worked with smaller customers who might have less data scientists. And one of the great things about Snorkel is we have an amazing team of ML engineers who work on the post-sale side to really provide hands-on assistance to ensure success. And as Andreas phrased it, get those impressive outcomes.
Man, I think the other thing I'll add there is that, the one of the big motivations behind Snorkel Flow is to be more efficient with SME time. I'm
Yeah.
thinking, there was a use case a while back where, I believe the customer wanted to identify journals. I think these are biomedical journals that might have information that was relevant to what they do. But as you can imagine, it's not a very scalable process to ask your SMEs to read, these really long, journals, especially when they're coming out every day. The idea was just to collaborate with SMEs early on to understand what is it that you're looking for in these journals, right? What is an indicator that this is worth reading or might contain information that's relevant to your task? Then they built and deployed that predictive model, and it was able to identify only those journals that were relevant. And then they go through like a second human process, right? Someone's going to actually have to look at it and be like, oh yeah, this really was a good, prediction. Glad we have it, or not. But that's always the challenge for almost everybody I talk to is nobody can afford to, retask entire SME teams to just data labeling or filtering for information in large documents, right? They all have day jobs. They're probably fairly expensive. So hopefully, Snorkel Flow is a way to alleviate, some of that pressure. Going down the list here, let's see. Okay, I'm going to work through this one here. Give you a moment, Grace. I'll set it up. This is a great one, though, as an example. Suppose I have a scanned copy of survey responses, right? A set of questions, a set of answer options for each question, and a user response by way of a check mark on these. The PDF is 10 scanned pages. The task is to extract a set of key value pairs where the key is the question and the value is the chosen answer. Now, this is not a use case of data extraction based on labeling. Well, how is the above task handled? So I'll do one little interjection here, and then Grace, I'll turn it over for the task handle. But one of the things that I think can be sometimes a little tricky is that for us, these are labeling tasks. So I know that conceptually, I want to identify the question and the selected answer. Under the covers, it's a labeling task for us because what we're trying to do is essentially, label both the question and label the selected answer, right? Once we have those labels, we can give you that key value pair that you're looking for. So I'm just going to insert that real quick that under the covers in our world, we tend to think of all these things as data labeling one way or the other. But I'll stop now. Grace, did you have some thoughts on this one?
Shane, I think you nailed it. That was exactly what I was thinking. I think even though I'm imagining in this case, your checked answer isn't always going to be like yes, no. It's probably going to be very specific to the question. You can still use a labeling function to label that answer as answer. And then again, as Shane said, this is still a case of data extraction based on labeling, but it is not as maybe uniform as this is always a patent label in this form. But again, you can still use labeling.
Yeah, I think maybe the way I wish I'd said it is I'm gonna kind of spitball here, but I would probably create a set of labels like Q1, Q2, Q3, A1, A2, A3. And then my goal was to try to label each of those questions, like label the first question Q1, label whatever the selected answer is Q1A or something like that. And then go back and then find those pairs of labels. So yeah, absolutely doable there. Let's see here. Okay, let's take a good one. How does your solution handle context-rich content, such as paragraphs that include not just specific data, but also associated metadata like dates and client names? Is the output structured in a way that allows this extracted data and its dimensions to be organized and applied to a relational database schema?
I am not up to speed on any of our relational database support at Snorkel. So I am going to copy this question, get the answer for you, and we will follow up via email.
Yeah.
Shannon, I don't know if you have any more context than I do.
Only a little bit more. So certainly we support native integration with most relational databases, right? There's JDBC out of the box, which is already going to give you, most of it. And then there are specialized adapters for Databricks and Snowflake, and a couple of others there. But again, this would probably get more into, I'd say the Jupyter Notebook space, right? So through the pre-processing and the data labeling, yes, we can grab things like dates and client names. What we're really doing is we're labeling, a span or a word, client name, for example, or client purchase date or something like that. I'm kind of making them up a little bit. Once we have those labels, then yes, you can do what you want with them, whether it's exported to a CSV or move it into a relational database. So those are all options. I'd say that the net of this, because I know we had a similar question earlier, is that Snorkel Flow is really helping you get the data, but then what you do with the data is kind of open-ended, right? Because these built-in notebooks. So you can write some Python to insert that into a relational database if you want to. It's really kind of up to you. We're just trying to make that process of actually getting, that metadata and noting it very easy for you.
So I do see one question about when a user uploads a PDF to Snorkel, does that doc go to Snorkel's servers? So Snorkel offers, you can use our own Snorkel cloud. You can do a hybrid running Snorkel in your cloud, or we also offer on-prem. And so depending on your company's needs, like maybe with security regulations, you can only run on-prem. You don't want that PDF data to ever be leaving your environment. That's a case where we would recommend on-prem. But of course, all of our data is end-to-end encrypted, and we are SOC 2 Type 2 compliant. And so I certainly trust Snorkel with my PDFs. And even before I joined Snorkel as an employee, this was a service that I used at prior companies.
Nice. Another one, this one kind of interesting. We can tease this one all bit. Do you guys use in-house models for table data extraction or document section structure identification? So that parsing, we have our own parser within Snorkel Flow that actually understands how to interpret those tables, break things down by section and paragraph, and so on. So I wouldn't really call it a model per se. There's other parsers out there and different types of products and tools. We happen to have our own, which has been built based on needs and experiences with our customers, right? So the more complex and sophisticated their documents are, the more we will kind of tune and enhance, our parser to make sure we're keeping up with those complexities. The only area where I'd say, you might touch on something like modeling is that, as you're creating these labeling functions, and you're providing kind of these heuristics or hints, on how to find the data that you're looking for. The final step of that is typically to aggregate that all. And so we have hopefully lots of label functions and pointers for what we're looking for. We kind of consolidate those results into kind of what we refer to as our label model. And that depends on how many are voting together, how many align with the ground truth. There's a whole bunch of magic that goes on there that helps us identify the ultimate final chosen label. And then I think we saw this in the demo as well. Then you can take those results and actually build a predictive model from within Snorkel Flow. And then deploy it wherever you like, right? Anything that supports MLflow is ultimately a target for where you can deploy that predictive model.
Another model related question, although slightly different. I think I'm seeing someone asking about the LLM. I think they're referring to the LLM that I used in the demo for creating a labeling function using a prompt. They're wondering what LLM I used. For this demo, I used GPT-4o, but we offer a wide range of options for those prompt labeling functions.
Nice. No, I think I saw this on your slide, but is the PDF expected to be a native PDF, or can it be a scanned image as a PDF document, i.e. OCR would be required?
Yeah, we support both. So it can be a native PDF. It can also be scanned. Pretty short and sweet answer. Just
Absolutely.
bring us your PDFs.
Let's see here. There is one I thought was interesting around how about the performance curve in a PDF file, whether Snorkel PDF services can extract information from the figure. The second question you might need to rephrase. I'm not sure if I caught that. But one of the things I can note, and Grace, you might have more information, is that in that pre-processing stage, we also do split PDFs into pages and other things. So we do try to parallelize some of this work and break it down into smaller pieces. So yes, we can't get around physics, right? That the bigger the document, the more work it's going to take. But there are some steps we can take to try to, mitigate that as best we can.
I like that. We can't get around physics. If we ever figure that out, we will definitely let you guys know. That'll be a big webinar.
Yes. I'm trying to go through here. We have quite a few questions, Grace. So if you see more that are popping out, you feel free to interrupt me and get that. Otherwise, I'm going to keep looking.
I see one on what can be done with low quality PDFs. The example they are giving is a scan of faxes. Um, Obviously, you would like your PDF to be as high quality as possible, but this is a use case that I would really um, you'd maybe want a couple more subject matter experts to do annotations to really establish as much ground truth as possible. Because maybe for the initial pass, a human eye might be able to identify some of the values on a poorly scanned PDF. And then again, you can go through that iterative process of creating programmatic labeling functions, scaling that up to the whole PDF. I personally haven't tried out Snorkel Flow on really low quality PDFs, but I think you just inspired an afternoon exploration for me.
Nice. Here's another one. Snorkel examples often pertain to PDFs. What about websites like community pages with a variety of articles, Q&A, blogs, et cetera, et cetera? Does Snorkel offer any agents to attach to such web content and allow for precision labeling similar to the PDF approach? My superficial response on that one is that while we focused on PDFs today, it's what we did was not exclusive to PDFs. So certainly, any sort of unstructured text is something that we can pre-process and label and annotate. I don't know that we have something specific to integrating with a particular file type, like an HTML. I don't think we're not going to, you can't simply give us the URL to our website and we'll pull that down, for example. That would be pretty awesome. But if you have the ability to grab, that text from those websites, certainly that can be imported into Snorkel Flow for pre-processing.
I think that is also a potential use case where a Jupyter notebook might come in handy because you
Mhm.
could use third-party functions to either convert that HTML into a PDF or extract the text from these websites another way and then pass that information into Snorkel Flow. So even though, as Shane said, we don't have a magic URL button today, I think we have tried to design our product to be as flexible as possible.
Nice. I think this is a good one too. I know we're kind of approaching the top of the hour here. Um, there's kind of two parts of this. The Snorkel label functions scale well if the PDFs have different structures. For example, 200 page plus PDFs, but the structure and content varies, greatly between these. There might be 50 to 100 different templates. Kind of as a first slot. The second question. You know what? Let's do that one first because the second question is a little bit different from that. But yeah, thoughts on PDFs where we understand there's going to be some variation in the structure and the content, and maybe we have a lot of templates.
Yeah, I think that's a great question. Part of the beauty of labeling functions is that you can write different LFs but still be applying the same label. Um, I have patents familiar in my head because that is what we were just looking at. But maybe you have a data set of US patents, but also patents from other countries, and the format of those patents varies. They probably all do have patent numbers, but they might be in different places. And so if you, the first thing I would do is try a prompt LF, see how many of those patent numbers it can identify, even if the PDF structure is different. But then if that's not good enough, but creating a labeling function for maybe those formats that it did not identify correctly, and then scaling it up that way. So the fact that you can write different labeling functions to identify kind of the same entity, I think gives you the flexibility so that your PDF structure on every page doesn't have to be identical.
Yeah, I think one thing I'll note there too is but you can have more than what I would say and Grace, you can help me if I get my terminology wrong here. Say Snorkel Flow application, right? You don't necessarily have to have one Snorkel application that covers every possible scenario. So you could choose to divide your workflow into a number of applications. And then the other thing I'll note is that the upper bounds on labeling functions is really quite high, to the point where it's usually not a concern. There's hundreds. I think I've even heard someone mention the thousands, one time. So that the upper bound is really, really high in terms of all the types of hints and heuristics and tips that you're trying to feed the system to extract this information. So I think we could work around it.
Yeah, I think that's a great call out, Shane, with the different applications. Like maybe you find it easier to say, hey, all of the PDFs in this format, we're shoving into this application, and do kind of an application per format. I think we can definitely handle it, and there are a number of different ways that you could approach it.
And then one last question here, and I know we didn't get to all of them, so we'll certainly try to reach out to everyone, afterwards. You'll get emails from us, and we're happy to connect with you and dive into more details. But one last one before we go. Do we have other independent benchmarks on RAG performance with and without Snorkel metadata tags? So I just wanted to kind of touch on this one a little bit. One, to get right away, no, I don't have a benchmark per se that I can share with you. But what we've seen in practice is it's really a matter of kind of evaluation improvement. So you need some way to evaluate the RAG system to even understand where the failures are occurring, right? Is it in retrieval? Is it in generation? If it is in retrieval, is it because the wrong chunks are being, brought in, or they're being, sorted, improperly? So there's different ways. So one thing I would say is we're going to need some form of evaluation, which is a topic for another webinar. But given that evaluation, if you've identified, that retrieval is an error, there are a number of ways to fix that with, kind of information extraction classification. We saw that kind of in that first RAG demo, where I know that, we had a customer that's use case was mentioned. They had kind of a predefined set of questions. I mean, think of it as document Q&A, but really it turned out to be 40, 50, pieces of information that needed to be extracted from these documents. It turned out that they were having a hard time with date related questions, right? And getting the right date. And so it would pull back chunks, and the chunks had dates, but they weren't necessarily the right date, right? There might be these subtle or nuance differences in the dates. And so we ended up kind of putting this through a classification information specialist, where we're essentially labeling the chunks as, hey, this chunk has the start date, this chunk has the cancellation date, or this chunk has, and then you can synthetically generate a question, or if you already have the question, pair those together, and then use those pairs to train the embedding model. So now it gets smarter at understanding that if you're asking for the cancellation date, it's not just going to grab any chunk that happens to, mention the word cancellation and it happens to have a date somewhere, which might be the cancellation date of something else. It might be a policy. So that's one way that extracting that information and kind of, creating that metadata can help you, improve your RAG performance. Other options, if you're kind of getting to more sophisticated side of things, is you could combine keyword and similarity search, right? So if you're extracting metadata in the form of keywords, and then you actually insert those chunks, embeddings, and keywords into your vector database, then, in your framework, whether it's LangChain or Llama Index, whatever you want to use, you could potentially do that retrieval both by, the similarity to the question, as well as any relevant keywords, right? So if I'm looking for just billing issues, I might send billing as a keyword along with my question embedding. That can help me filter down the results more specifically and ultimately actually much faster. So this was kind of a little bit of what I teased at the beginning, that even though we're talking about predictive, kind of classical predictive scenarios of classification and extraction, they ultimately have actually a pretty big role to play, and even in Gen AI fish as well. That's my concluding bit. Grace, do you have any final thoughts here before we wrap up?
I think Shane, you wrapped it up beautifully. So let's leave it on that.
All right. Thank you again, everyone, for joining us. We appreciate your time, and we will see you hopefully not too far from now.
Thanks, folks.